today I'm talking about Lustre 2.12 and other future developments that we're working on at Whamcloud. So there are a number of features that we're working on for the very near 2.12 release. Many of these are, well, all of these are already landed into our repository and will be arriving in the next few months when Lustre 2.12 is released. And we're also working on a number of further features for 2.13 and 2.14 as well. One of the interesting features that has arrived in Lustre 2.10 was the LNet multi-rail support, which allows multiple InfiniBand or Ethernet or other network adapters to be bonded together for performance reasons. This allows increasing the network bandwidth to a single node, either a server or a client. And in the Lustre 2.12 release, we're improving this to allow failover due to fault on the network and automatic detection of network errors. This will improve the reliability of the Lustre networking, in addition to improving the performance that was arriving in 2.10. As well, there's work discussed for the called User-Defined Selection Policy, UDSP. This will allow fine-tuning the LNet multi-rail to be able to select between different network types, such as InfiniBand and Ethernet, so that you can prioritize traffic between those network types. Right now, it will load balance over them based on the bandwidth, but there isn't a way to specify, use one network as the primary, such as InfiniBand, and then only use a TCP network as a backup. Data on MBT is also another feature that arrived recently in the 2.11 release, and this allows storing small files directly on the MBT, which allows lower overhead for accessing small files because you don't store the metadata on one node and the data on another, so it reduces the RPCs. As well, typically the MDT has faster storage, such as flash, and it's in RAID 10 configuration, so there's not a large overhead from doing read, modify, write small files that are smaller than a stripe size on a RAID controller. As well, one of the important benefits we've seen with data on MDT is separation of the workload, so that small file I/O doesn't interfere with large streaming I/O going to the OSTs. So this has shown good performance improvements. In 2.12, we're continuing to improve the data on MBT performance by allowing the file data of small files stored on the MBT to be read at open time, so that if a client opens a small file, it will fetch the attributes and the file data in a single RPC. This is currently limited to files smaller than 32 kilobytes in size, but might be improved, increased in the future. As well, there's improved locking, such as the lock conversion, which allows clients to continue caching a file that was written if another client accesses the file by downgrading a write lock to a read lock, so that it reduces unnecessary network contention. As well, in the 2.12 release, it's possible to migrate if a large file has started being written to the MDT, and then it grows larger than the MDT file size limit. It would continue writing the files onto the OSTs, but there would remain a small component on the MDT. And so in 2.12, there'll be a mechanism to migrate the data on MDT component to be on the then you reduce your space usage on MDT. In the future, for 2.13, we'll allow doing the reverse. If you have a file system that has small files that were created on OSTs, you'll be able to migrate those small files to be on the MDT. As well, another feature that we are discussing, the cross-file read ahead. We already have a mechanism called stat ahead, which allows fetching attributes on files. If you're doing a read dir inside a directory and you're accessing all of the files in sequential order inside the directory with read dir plus stat, we prefetch attributes across files, and then we're looking at doing the same thing for small file data, so that if you're doing a grep or other workload that reads many thousands of files inside a directory, we can prefetch the data, because for small files, the normal inside the file read ahead is not going to be effective, because you finished reading the data before you detect a sequential read pattern. As well, DNE, which is distributed namespace. It allows multiple MDTs in a single file system. And in 2.12, some of the improvements that were developed, we allow directory restriping from a single stripe directory to be a multi-stripe directory, so that for very large directories, existing directories, you can distribute that across multiple MDTs using an administrator command, LFS migrate, and that allows you to better space balance file systems if you're adding MDT capacity into an existing file system. As well, if you specify, if you use the LFS make dir command, you can specify the LFS make dir -I command, and it will pick the best MDT by size, or available space, I should say, so that it simplifies usage for administrators and users. Both of these are intended to make the DNE feature more easily used by users. Ongoing work that we've started for the 2.13 release is automatic MDT load balancing inside the kernel when you're doing a regular make dir call instead of LFS make dir. We would also select a better MDT so that you get automatic load balancing across MDTs, and improving the directory restriping feature that's currently implemented through the LFS migrate command in user space to allow automatic directory restriping for very large directories inside the kernel. And this allows, in a similar manner to the progressive file layouts feature, this would allow large directories to automatically be split across multiple MDTs, again, to make it easier to use the DNE feature on multiple MDTs without any user or administrator interaction. As well, one of the areas that's receiving lots of development effort, both from some from Whamcloud, but also from other people interested in ZFS. We're tracking the ZFS 0.7 maintenance releases, but it should be noted that there are some ZFS releases that are not safe to use, and so we have avoided those for the Lustre release. But we're also tracking the ZFS 0.8 branch to make sure that Lustre 2.12 will build with that when it becomes available. We're hoping that the 0.8 release will be available in the next few months, but it's not totally clear when that release will be made. But it does have a number of interesting features that were developed, both when we were in the team at Intel and by other companies. Sequential scrub and resilver will improve the performance when a disk needs to be replaced by making it more similar to a regular RAID rebuild by doing the I/O sequentially rather than in the typically random order that ZFS does it today. On-disk encryption is handled inside the ZFS layer, and it was mentioned earlier that there's Intel QAT hardware acceleration for encryption and checksums, the QAT hardware, and so that was integrated into the ZFS on-disk encryption code. So Lustre doesn't handle the encryption directly. There needs to be an external key management mechanism, but once the file system is unlocked, then Lustre could mount it, and you'd have persistent on-disk encryption. As well, Project Quota was a feature that we developed at Intel for ZFS. It had previously existed on LDiskFS. Device removal is useful if people make configuration errors or they want to retire old hardware. And metadata allocation class is similar to the Lustre file system. It separates metadata from data on the storage devices, so you can put metadata on a flash device inside of ZFS and have high IOPS there, and then use spinning disks for most of the data. And this will improve not only metadata access but also scrub and resilver as well. And then an interesting feature that many people are interested in, declustered parity RAID. The feature is mostly finished development, but it's still not landed into the 0.8 release yet. And so that's one of the last features that's going to be landed for 0.8. There's a number of other smaller improvements, such as UID and GID for the token bucket filter. That allows specifying QoS policies so that you can balance performance for different users in a cluster so that they don't consume all the bandwidth or IOPS on a server. Improved job stats, also improvements for HSM so that you can have better performance and more consistent behavior under load. Lazy size on MDT is a feature that allows tools that scan the MDT directly to also get an estimate of the file size without having to talk to the OSDs. And that allows tools such as policy engines or backup scripts to have an idea of the file size without the overhead or complexity of keeping the MDT size completely up to date. And so it's not guaranteed to give exactly accurate file size, but if you have a policy that is saying files larger than a gigabyte, back them up every week, or files owned by a specific user, that are smaller than a certain size, put them into a different storage pool or something like that. You can use the size on MDT, the lazy size on MDT. There's also work underway to integrate this with LFS find so that you can do fast scanning from clients without the file size being directly impacted by this. As well, one of the features that DDN worked on, so lazy size on MDT was also developed by DDN engineers before we joined Whamcloud and DDN. But the T10 PI is hardware-assisted checksums on disk and controller hardware, and we've implemented client-side support for T10 PI so that it will compute the same checksum and pass it to the server. And this allows the server to use the client-provided checksums directly and verify them. So it reduces CPU overhead at the server. And another feature that is nearly done, and might still be in 2.12, is the dump and restore of configuration parameters. This allows saving parameters so that you can see if they change over time, or if you need to rewrite the Lustre configuration for some reason, you can save the tunables. Other work on the client has designed for large-scale systems. One is to allow clients that are not talking to an OST for some time to disconnect, so that it reduces the memory usage at the client and the OSS. And it also helps with recovery, so that if there's fewer clients connected to a server, if it crashes, then they don't need to participate in recovery. And this simplifies the recovery and speeds up return to service. It also reduces network pings for idle systems. In order to facilitate the idle client disconnection, we also aggregated StatFS so that it can perform the StatFS operation with a single RPC to the MDS, rather than communicating with all of the OSTs. And this avoids idle clients reconnecting to OSTs just because of DF. There's, for the 2.13 release, there's improved read-ahead code under development by DDN, and reducing wake-ups and other operations from the Lustre client to avoid jitter on compute nodes, and reduced overhead and memory usage. There's also work done to optimize flash performance, to reduce CPU usage on the server, because with very high IOPS rates and very high bandwidth flash storage, the CPU becomes a significant bottleneck. And so we've been doing performance profiling on the server under heavy 4K read IOPS to reduce, we found areas that were easily modified to reduce CPU usage. And any amount of CPU reduction directly translates into increased performance with the small IOPS when we're not limited on the network bandwidth. Another option is for flash storage to avoid using page cache, because the IOPS rates are so high from the underlying storage that page cache doesn't provide any significant improvement. And so we do direct I/O, and this avoids CPU usage from inserting and removing pages into the Linux kernel page cache, and has also improved performance significantly. These two changes together nearly doubled the flash performance, the IOPS performance for 4K reads. We're going to, this was on LDiskFS, the page cache avoidance is mostly for LDiskFS, but we also did similar work for ZFS, and there's more optimization underway for ZFS in the 2.13 release. The file level redundancy is also a feature that was introduced in Lustre 2.11. This allows Lustre to mirror files across multiple OSTs, and so this can improve read bandwidth. It also improves fault tolerance in case of an OSS failure. We don't have to wait for server recovery to complete before reading the file. And one of the good features of FLR is that it can be tuned, the mirroring, on a per file basis, so that, for instance, files that are in a job queue that are waiting for a compute resource allocation, they can be mirrored to ensure that the files are accessible when the job starts, or if there's files that are being read by many nodes at a job launch, they can be mirrored widely to improve the read bandwidth across multiple OSS nodes. And so to improve upon the functionality that was added in 2.11, we've improved the allocator for the objects to ensure that the mirrors are not on the same OSS nodes. Also, the tool that synchronizes mirror copies, they become out of date. We've optimized the read performance so that it only reads the data once when it's resyncing instead of reading it once per mirror copy. There's some new commands, LFS mirror read and LFS mirror write, which allows you to read or write a specific mirror of the file. And typically this would be used for a user space resync tool if you want to write your own resync tool. But there's also a no sync flag that can be added onto a mirror. And so what this can allow is if you disable the resync on a particular mirror, and then you can use it to read an old version of the file. So this is the beginning of the support for implementing file versions. And so there isn't a proper implementation of version files yet, but some of the functionality has been added. Future work in this area is to have a direct server local client that allows optimized resync of files directly on an OSS node. Mirroring of data on MDT components, which is not possible yet. And also pool and OST and MDT specific quotas so that you can restrict usage of flash-based OSTs from the regular disk-based OSTs to ensure that users who know too much don't put all of their files on the flash OSTs. As well, erasure coding is being designed today so that in addition to file mirroring, you can also do erasure coding and strike files to reduce the space usage. Another feature that DDN developed is persistent client cache. I won't go into too much detail. It's been discussed somewhat already, but it's designed to allow optimized client local I/O without communicating over the network to the Lustre file system. And so this is, since it's integrated into the Lustre namespace, it's transparent to applications, but avoids the network overhead and latency. And one of the early stages of development for the client metadata write-back cache, we have a prototype of this implementation of this feature. It allows the client to create files in a new directory, doing all the operations completely in RAM without communicating with the servers, either the MDS or the OSS. And so for a new directory, all of the names, the directory is empty, so there's no worry about name contention. And so all of the names can be created locally, all of the files can be written locally, and in our testing for workloads like untar or kernel compiles, it can speed up the performance dramatically because there's no network latency and no storage latency. And so we saw in some tests 10 to 20 times improvements, but the prototype implementation today doesn't have any resource management, so it doesn't limit the RAM usage and it doesn't flush into the background. Right now the only mechanism is to flush on block contention, so if another client tries to access the directory, it will flush consecutive levels of the directory to avoid or to release the resources that another client is accessing. But so it needs more work, but it's very promising. development. And in a similar but orthogonal development is the client container image. People have been using LDiskFS client mounts for some time to provide small file I/O. This is mounted, it would be a loopback on the client, but we would like to be able to integrate this into the Lustre namespace so that it's transparently visible to clients. The container can, is an efficient way to hold a large number of small files, and then once it's part of the Lustre file system, it can be managed efficiently as one unit. For instance, if you want to tar up, archive a large number of small files into an HSM, it's not very efficient for the HSM to process the files individually, but if you have a disk image, it can be archived as a single unit and retrieved from storage as a single unit without having to process individual files. But this is still just in the design phase today, and maybe 2.14, but it would be the start of the development, but it won't be finished by then. I think that's it. Any questions?
I'll just ask, I guess, for DNA you have some round robin load balancing, but do you have anything like directory tools planned? So you could isolate, one reason we're using DNA one is isolate populations.
Yeah.
So we have some populations that we know behave badly on one server as another, and we would like to see some DNA pools. So the same population could use a few servers, the rest could use another few servers.
So DNA pools, so MDT pools really. We've talked about it. It hasn't, come up as a priority yet, but it's definitely something we thought about. It's not clear whether, should we have separate MDT pools from OST pools, or do we want the two to be tied together? But it's also for quota reasons, because with data on MDT, we don't want users to be able to fill up all of the MDT space. So for that reason, you may also need to have MDT pools, but it hasn't come up as a requirement yet.
他にご質問のある方はいらっしゃいますでしょうか。アンドレアス・ディルガー様、ありがとうございました。